All right, on tonight's episode of Python Papi, we're back inside our artificial intelligence course and we're still doing our learning module. Let's have a look at what we went over tonight. Now, last night, if you recall, the last thing we went over was the 0, 1 loss function, and tonight we're going to build on top of that. So the way this works is, for each of the data points, our loss function takes as input what the actual output is, like whether it was actually raining or not, and takes some prediction into account. Did we predict, given this data point, whether it was raining or not? And if the actual value does equal the prediction, well then the 0, 1 loss function will just say 0. There was no loss of utility because we were able to predict correctly. And otherwise, if the value is not the same thing as what we predicted, well, in that case, our loss is 1. We lost something. We lost some utility because what we predicted the output of the function was not actually what it was. And the goal in a situation like this will be to come up with some hypothesis that minimizes the total empirical loss, the total amount that we lost if we add up all of those data points and what the actual output is and what our hypothesis would have predicted. So in the case, for example, if we go back to classifying days as raining or not raining, and we came up with some decision boundary, how will we evaluate this decision boundary? How much better is it than drawing a line to the far left or the far right? Now, if you recall, we went over this model here in one of our previous modules. We have a line going straight through our X's and O's. X's represent not raining, O's represent raining, and we have it going straight through the middle as opposed to the far left or the far right. So that's what they're saying there. Where we could take each of these input data points, and each input data point has a label, whether it was raining or whether it was not raining, and we could compare it to the prediction, whether we predicted it would be raining or not raining, and assign it a numerical value as a result. So for example, our O data points, they were all rainy days, and we predicted they would be rainy because they all fall on the right side of our line. So they have a loss of 0. Nothing lost from those situations. And likewise, the same is true for most of the X data points where it was not raining and we predicted that it was not raining. Where we do have loss are the 0 data points that fall on the left side of the line and the X data points that fall on the right side of the line. Let me go back so I can show you that. So you can see here we have the O's on the left side of the line. We have some X's on the right side of the line. So that's where we have a little miscategorization right there. So where we predicted that it would not be raining, but our X data point fell on the right side, and likewise where we predicted that it would be raining, but the O data point fell on the left side. So as a result, we miscategorized those data points that we were trying to train on, and as a result, there's some loss. Each data point that was miscategorized will count as a loss of utility. Now we did go over a lot more, but I'm not going to go over everything tonight. But we will pick it up tomorrow, and I will keep you guys posted every step of the way. But for now, this is the Python Poppy. You guys stay Gucci.